Hello guys, in this video we are going to be discussing the solution to the problem invertible bracket sequence which appeared in the educational Codeforces round 166. So in this problem they are going to be giving us a regular bracket sequence. When is the bracket sequence a regular bracket sequence? A bracket sequence is a regular bracket sequence when it satisfies this property. So suppose we are assigning plus 1 to an opening bracket and minus 1 to a closing bracket. So what will be the total sum of this? So this will be a plus 1, this will be a minus 1, this will be a plus 1, this will be a plus 1, this will be a minus 1, this will be a minus 1. So we are finding the total sum of this. Sum till here 0, sum till here 1, sum till here 2, sum till here is 1, sum till here is 0. So for a regular bracket sequence the total sum should be equal to 0 and at no point the sum should become less than 0. So if at a point the sum becomes less than 0, it means that the number of closing brackets at that point till that point is greater than the number of closing brackets is greater than the number of opening brackets. So that is not a valid condition for a regular bracket sequence. So that would violate our condition. So what we have to find is we have to find the number of what word did they use? Okay, number of substrings. So this is a substring. Substring is a continuous piece of string. So this is a substring. So we have to find the number of such substrings such that if we take the inverse of this substring, this entire string becomes this is the same, but we are taking the inverse of this substring. The inverse of this substring will become this. So we wrote the opening bracket. We wrote the closing bracket for the opening bracket and we wrote the opening bracket for the closing bracket. So we took the ulta of the brackets that they have given us. So and we have to find how many such substrings we can take inverse such that the conditions for the regular bracket sequence is maintained. Is the condition for regular bracket sequence maintained here? Let's see. So this is plus 1, this is minus 1, this is minus 1, this is minus 1, this is plus 1, this is minus 1. The sum till here is 0, the sum till here is minus 1, the sum till here is minus 2, the sum till here is minus 1, the sum till here is minus 2. So the total sum is equal to minus 2, which is not equal to 0. So that violates our first condition, as well as the sum at a point has become negative. So if a sum at a particular point has become negative, it also violates our condition. So these are the two conditions to checking whether a particular sequence is a regular bracket sequence or not. So actually this problem is very easy. Like I have used, my approach is a greedy approach which with a small segmentary implementation. The segmentary is not the main part of it. It is just to find out the minimum value in a range. You can use any other method to find the minimum value in a particular range. You could have used anything, right? I just used a segmentary for the particular operation. I used a segmentary, that's it. You could have used anything to find the minimum value in a particular range. So I will explain my solution. In my solution, what I do initially is that, okay, now I will give you two observations. The first observation is that, so suppose this value, the value of this particular substring is a value called val2. So this is the value for this particular substring. So for this particular substring, what will be the value? The value will be 1 plus 1 plus 1 plus 1 plus minus 1. So it will be equal to 1. So for this particular substring, the value 2 will be equal to 1. And suppose the value before the substring is equal to value 1, and the value after the substring is equal to value 3. So according to our regular expression condition, value 1 plus value 2 plus value 3 should be equal to 0. So this is according to our regular expression, regular bracket sequence condition. But they have asked us to flip this particular value 2. So when we flip this, the brackets that correspond to this value 2, this value becomes negative, so it becomes the opposite. So the expression now becomes value 1 plus value 2, value 1 minus value 2 plus value 3 is equal to 0. Since we have flipped all the brackets in this, the value also gets like the opposite. So here initially the value was equal to 1. When we take the inverse of all the brackets in that sequence, what will the value become? So the value will become, let's take minus 1 plus minus 1 plus 1. So what is the total value? Minus 1. So it became negative of the original value. So if it was negative 1 over here, it would have become positive 1. And if it was like negative 3 over here, it would have become positive 3. So it becomes negative of it. Now how will we solve for this particular, how will we solve these two particular equations? We will solve these two particular equations by adding both of them. When we add both of them, we will get the equation 2 value 1 plus this value, value 2 will get cancelled. Value 2, here is a minus value 2 and here is a positive value 2. Those both will get cancelled, and we will be left with 2 value 1 plus 2 value 3 is equal to 0. We will divide both sides by 2, then we will get value 1 plus value 3 is equal to 0. So this will be the first condition, first equation. And the second, so from this we can derive that substituting this in either the first equation or the second equation, we will get value 2 is equal to 0. So we got an interesting observation over here now. So any substring that we choose, the sum of that substring should be equal to 0. So this is one condition that we have to follow. So if we choose a particular substring that has value is equal to that has total value equal to 0, there is a possibility that if you take the inverse of it, if you take the inverse of that particular substring, it will still be a regular bracket sequence. It's not a like necessary condition. If the total value equal to 0, the inverse of it will also be a regular bracket sequence. Like, it's one of the conditions to satisfy. So this is one of the conditions to satisfy. The other condition to satisfy is that we know that value 1 is the value of the bracket sequence before the substring. Value 1 should be greater than or equal to value 2. Value 2 is the value of the substring that we chose, right? Only if and only if this satisfies, actually minus value 2, this is the value of the the inverse substring, right? So only if and this satisfies. Okay, so if both of these conditions satisfy, we will get a valid substring. So we can take that substring and we can take the inverse of that, and we can take the count of that. So these are the two conditions to satisfy. And to find the number of substrings who has value equal to 0, it's very easy. Like, it's a standard LeetCode or Codeforces problem. So we just have to find initially we just have to find the prefix sum of the entire array, and we just have to keep a count of all the values. And okay, I will tell you. So suppose the values that we have is 1 minus 2, 2 1 3 4 minus 3 4. Yeah, so this is a suppose this is a array. So I'm gonna why have I chosen this array? To explain how to find the substrings with count the number of substrings with the value is equal to 0. Okay, so when I take the prefix sum of this, the prefix sum till 1 will be equal to 1, till here will be equal to -1, till here will be equal to 1, till here will be equal to 2, till here will be equal to 5, till here will be equal to 9, till here will be equal to 6, till here will be equal to 2. So and till here will be equal to 1. So okay, now we took the prefix sum. Now to find the subarrays which have sum is equal to sum is equal to 0, what we have to do is that, so when we reach a particular point, we will check how many points before this point have the same value -1. No points before this point have the same value -1. So there is no substring with which is ending in so if there was a value -1 before this, from that particular -1 till here, the total sum would have been 0. Okay, I will give an example. So we have a 1 over here, right? We have a 1 over here and we have a 1 over here. So if we take why is there 2 ones over here? Because we have a 1 over here and we have a 1 over here, because the total sum in between these two ones became 0. That's why we got 1 over here as well as 1 over here. Okay, okay, I will show you here. So the index corresponding to this one is 2, right? The index corresponding to this one is 1 2 3 4 5 6 sorry 2 3 4 5 6 7 8. So if you take the total sum in between this index and this index, and we have to include this index as well, okay? In between this index and this index and including this index, the total sum will be equal to 0. 1 plus 3 4, 4 plus 4 8, 8 minus 3 5, 5 minus 4 1, 1 minus 1 is equal to 0. So we got the sum is equal to 0. So the total sum in between this one and this one will be equal to 0, as well as the total sum in between this one and this one will also be equal to 0. That's the speciality about prefix sum. So if we keep track of how many ones are there before this particular one, so there are 2 ones before this particular one, so there are 2 substrings that are ending at this particular index which have a sum 0. So this is one substring and this is one substring. So both these subarrays have sum is equal to 0 and both of them are ending at this particular index. Right? So this is how we compute the number of substrings which have a value equal to 0. But we have to satisfy this condition as well. So I will give you how we are going to satisfy this particular condition. It's also easy. That's where I am using the segmentary for a small part of the implementation. So suppose I give you an example. The example is opening bracket, opening bracket, opening bracket, opening bracket, opening bracket, closing bracket, closing bracket, closing bracket, closing bracket, closing bracket. And if I take the substring, this is the substring that I am going to choose. Okay, this is the substring that I am going to choose. Now, this is a substring. Okay, this is a substring that I want to choose. This is a substring that I want to choose. So the total value of this particular substring is equal to 0, right? But okay, when we reverse it, the new string becomes this. Okay, actually there is one. The new string becomes, no, there was no need for it. The new string becomes this was the reversed substring. Now if you take the sum from the beginning, this is plus 1 plus 1 plus 1 2 minus 1 is equal to 1 1 minus 1 0 0 minus 1 minus 1. So when we reached here, the sum became negative, even though the sum of this particular substring is equal to 0. When we took the prefix sum till here, the sum became negative. So it violates the condition of regular bracket sequence. So we have to eliminate these substrings. So initially we will find the total number of substrings which have a value equal to 0, and we have to eliminate from that total count these substrings which violates the second condition, which violates this condition. So how will we do this? How will we do this? So what I am going to do is that I am going to initially compute a reversed prefix sum array, you can call it that. So in that reversed prefix sum array, I am gonna initially reverse the entire string at once. I am not taking any particular substring, I am initially reversing the entire string. When I reverse the entire string, the string becomes this is the reversed string. Now I will compute the prefix sum on this. So the prefix sum till here is minus 1, minus 2, minus 3, minus 4, minus 5, minus 4, minus 3, minus 2, minus 1, 0. So I computed the entire prefix sum over this array. Now why am I doing this? I am doing this because to make it more convenient. Why do we usually compute prefix sum? So if you want to compute the sum for this particular interval, if we compute the prefix sum, we can just just subtract the prefix sum till here, minus the prefix sum till here. We will get the sum of this particular substring, right? So that's why I am basically doing here as well. So when we want the sum of this particular reversed substring, I am going to use this reversed prefix sum. Okay. Now what I am going to do is that, now I am going to compute the smallest value in this range. I am going to compute the smallest value for this particular substring. The smallest value for this particular substring, if we check the reversed prefix sum array, it will be equal to, so this is the substring that we are considering. The smallest value in this particular reverse substring array will be equal to minus 5. So why are we taking the smallest value? Because smallest value will be most likely be the breaking point. Here when we reach this particular bracket, the sum became negative, right? So if we take the smallest value from this reversed prefix sum array, it will most likely be the breaking point, or the point where it gets violated. So we can take any other point, any other value as well, but to get the optimal value, it will be more useful taking this particular value. So we got minus 5. Minus 5 is the value that we get when we take the value from the beginning. So to get the value, sorry, I got a call in between. So okay, where did I stop? Okay, so this minus 5 is the value that we computed from the beginning of this reversed prefix sum array, right? So to get the value from this particular index, we just have to subtract minus 5 with the minus 2, right? So minus 2 is the value corresponding to this particular index. So we just have to subtract minus 5 and minus 2. So we will get minus 5 minus 2 will be equal to minus 3. Okay, that will be the value here. So it will be minus 1, minus 2, minus 3. It's correct. Minus 3. Now we will compute the the prefix sum, the not the reverse prefix sum, the original prefix sum, uh, till the starting of the original string. Why are we doing this? Okay, we are doing this because like uh, when we reach here, the value will not be entirely minus 3, right? The value will be the value, this value plus minus 3. So what is the prefix sum of this particular substring? It will be 1 plus 1, it will be 2. So the actual value over here from the beginning of the array will be equal to minus 3 plus 2. It will be equal to minus 1. It's actually the correct value, right? Minus 1 will be the correct value. So when we start from here, the value will be minus 3, but when we start from here, the value will be minus 1. That's the value that we want to compute, because that's the value that we are checking for. And now after we computed that value, since this value is lesser than 0, uh, this condition gets violated. This condition gets violated and we can't use this particular substring. So we did all this operation to check whether this condition is getting satisfied or not. To get the substrings that satisfy this condition, it's pretty easy. I told you, using this particular prefix sum array, we can compute that. But we have to check whether the subarray that we computed using this particular condition satisfies this condition as well. But that's the hard part of this question. But as we have seen, it's not really hard. So what we did is we computed the reversed prefix sum. Then we found the smallest value in the reverse prefix sum that belongs to the the substring. Then we subtracted that with the beginning starting of the the value at the starting of the substring. So that will be the value when we compute the value of the reverse substring from the starting of the reverse substring, minus 3. And then we add the total value before that to the minus 3, then we will get minus 1. Since minus 1 is lesser than 0, this substring is not valid. So that's how we eliminate the invalid substrings. Now I will show you the code for this. It's raining heavily outside, so you may hear some disturbance. Okay, okay, this is the code for it. So I am initially inputting the string. I am computing the size of the string. This sum value will store the suffix sum. So here, instead of prefix sum, the code is very simple. Actually, the code is very simple. The code is only, okay, actually the code is only this. This is only the code. Here I am just calculating the prefix sum, reversed prefix sum. Then here, this is the segmentary code. As I told you, as I am using segmentary just to find the minimum value in the range. Yeah. So this sum value will hold the suffix sum. Instead of prefix sum, I found it more useful to, okay, why am I using this suffix sum? To compute the number of substrings which have the value 0. I told you, right? That's the first condition that we want to satisfy, and I am using this to store the suffix sum. You can use a prefix sum as well. I am using a suffix sum here. Okay, now here I am computing the reverse prefix sum, and here I am computing the prefix sum. So reverse prefix sum, I am taking the opening bracket as -1, and for the correct prefix sum, I am taking the closing bracket as -1. Yeah, that's it. And then I am taking two maps. So the first map is the count map, to count the number of occurrences for a particular value. So I told you, right, for to compute the number of substrings which have subarrays which have a value 0, we have to, so to find the number of subarrays which have a value 0. If suppose the value that we are currently on is 1, we have to, so this can be anything, this can be anything in between, this can be anything in between. So we have to compute the number of ones before this. So the number of ones before this, so since I'm taking the suffix sum, I will come from behind, and to find the number of subarrays which have a value 0, we have to count the number of ones which occur before this particular one. So the number of ones before this particular ones will be equal to is equal to 2, since there are two ones over here. So the number of subarrays which are ending at this particular index, this will be the leftmost index for that subarray. The number of subarrays which with this particular left index will be equal to, this is one subarray, this is one subarray, will be equal to 2. Yeah. So that's why I'm using this count map over here to compute the number of occurrences for a particular value before that particular value. And I'm using this last index map to compute the occurrence of the, okay, for this particular one, I'm inside this last index map, I will store the occurrence of the last one. So this is the current one, this is the last one, and I will store this particular index, the index inside here, inside this map. Why am I doing this? Okay, why am I doing is that I told you, right? I told you that we have to satisfy two conditions for to reverse that particular substring. The first condition is that the value of the substring should be equal to 0, and the second condition is that the value 1 should be greater than or equal to value 2. So if 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 the second, so uh, these are the two substrings that satisfies the first condition, right? These are the two substrings that satisfies the first condition. And to check the second condition, we only need to check for this particular substring, subarray or substring. We only need to check for this particular subarray. If the second condition fails in this particular subarray, it's 100% sure that it will fail for this subarray as well, because for some value, from when we are computing the sum from the beginning, and for some value, if the second condition has to fail for some index, the sum has to become less than 0, right? So suppose this is the index where the sum becomes less than 0, so we can't take this particular subarray, because inside this particular subarray, for this particular index, the sum has become less than 0. Since this index is also a part of this index, this subarray as well, so this subarray also gets invalid. So since this index is part of this subarray as well as this subarray, uh, we don't need to consider any subarrays before this particular index. So that's why what I'm doing over here. So yeah, so we only need to compute for the first subarray, and if it fails the condition, then all subarrays ending at using all subarrays using this particular index, using this particular index as the leftmost point, will also fail. So that's why I'm computing only storing the last index. Okay, yeah. And now what charges are there? Now we will go to the main part of the code. Okay, I will also show you the segmentary implementation. Okay, I'm building the segmentary. This is the minimum segmentary implementation. Uh, I don't know the exact name. Min segmentary, right? Min segmentary. Yeah, I guess it's min segmentary. Yeah. So building the segmentary, when I reach a node which has single value, I'm returning the value, and I'm taking the minimum of the left and right child, as well as when I'm taking a query, I want, okay, you know the min segmentary implementation, right? Like if I explain it as well, like The video will be very lengthy. I will go to the main code implementation. The segmentary is not a major part of this. It's just a data structure that we are using to find the minimum value in a particular range. That's a very like that's a very no like not a key part of this concept. Key part of the logic. Key part of the logic. Yeah, yeah. This is the main greedy code. So I'm starting from the back. I'm computing from the back, and I'm computing the suffix sum. If it's a opening bracket, I'm giving it as a plus one value, and if it's a closing bracket, I'm giving it a negative value. And for this particular sum, I am computing the if any sum, any uh, index was there which had the same value as sum. So if there is no index which had the same value as sum, this value will become equal to 0, and then we won't check this particular condition. Then we will increment the count of sum by 1, and then we will put the last index of the sum to the current index. But if there was a last index of this particular sum, if there was another occurrence before of this particular sum before this particular sum, then what we will do is that this check val uh, okay, this check val is okay, this inside this check val, what we store is that, so suppose this is the reverse substring, and this is the entire reverse substring, and the substring that we want to consider is only this much. So what we will do is that we will find the uh, you know entire reverse substring, and then we will subtract this particular part, right? So to subtract this particular part, I am computing the reverse till the I minus 1. So currently we are suppose we are at this particular index, and we are only we are only considering, okay, suppose we are only considering this particular substring. So we don't want the values associated with these values. So to subtract that, we are storing check reverse of minus I minus 1 inside here, and total will be the value of the original substring. That's the prefix sum. So this is the original substring till this particular index I. So what is this value? This value will be equal to 3. Okay, when I'm thinking it about it now, actually okay, this check val will be always be the negative of this total value, right? So there was no need to compute this as well. Okay, I'm thinking about it now. Okay, there was no need for that. Okay, for understanding purposes, it's good. Now here I'm calling the segmentary. I'm calling the segmentary to find the minimum value between the ith index, that's the current index, and index minus 1. Index is the last occurrence of this particular sum value, but we don't want to consider that. We don't want to consider that particular index. We only want to consider till that particular index. So we are only calling till index minus 1, and I am checking whether total is the prefix sum till I, compare val is the minimum value, and check val is the reverse prefix sum till the ith index. I'm subtracting the minimum value minus the reverse prefix sum, then I'm adding it to the total prefix sum, and I'm checking whether it is greater than 0. If it's greater than 0, it's a valid substring, right? So I told you, so it satisfies the second condition as well. It satisfies the first, satisfies the first condition, as well as it satisfies the second condition as well. But if it doesn't satisfy this condition, I told you all the subarrays before this particular sum will become invalid. So we can put the count, count of this particular sum is equal to 0 because all the subarrays before this particular subarray just became invalid. So that's why what I'm doing over here. Otherwise, we will add it to the total and add it to the total answer. So this is the entire approach and the code. I hope you have understood. Like, can you comment down below whether you have understood the code or not? And if you have understood the code, like, can you comment? Uh, can you like or subscribe or do both? Thank you.